The temperature on the surface of the Sun is approximately 5,500 degrees Celsius. However, if we talk about the inner core of the Earth, its temperature is approximately 6,000 degrees Celsius. Now, why is it that the source of energy for the entire Earth, which is the Sun, has a surface temperature lower than the inner core of our planet? We all know that nuclear fusion reactions are constantly happening inside the Sun, which is why the surface of the Sun is so hot. But inside our Earth, there are no nuclear reactions happening that could make it as hot as it is. To understand this, let's break down Earth into four main layers: the crust, mantle, outer core, and inner core. The layer where we live, the crust, is relatively thin and cool compared to the other layers. Life on Earth is primarily supported by this thin crust, which is composed mainly of light elements like silica, aluminum, and oxygen. The Earth's crust is approximately 60 kilometers thick and is divided into two parts: the continental crust, which covers landmasses, and the oceanic crust, which is entirely covered by water. Beneath the crust is the mantle, which is approximately 2,900 kilometers thick. The mantle is primarily composed of semi-solid rock known as magma. As you go deeper into the mantle, the rocks become softer, and deep within, they start to melt. It is in the mantle that most of the Earth's geological activity, such as volcanic eruptions and the overall dynamics of our planet, takes place. The movement in the mantle creates convection currents, which, in turn, drive the movement of tectonic plates on Earth's surface, leading to earthquakes. After the mantle comes Earth's outer core, often referred to as a hot metallic ball. The outer core is so hot that the metals in it are in a molten state. It is approximately 2,300 kilometers thick and consists mainly of molten iron and nickel. This outer core plays a crucial role in protecting life on Earth by generating a magnetic field that shields our planet from harmful solar winds and charged particles. Finally, beyond the outer core lies Earth's inner core, located at the very center of our planet, approximately 1,200 kilometers thick. The temperature in the inner core is around 6,700 degrees Celsius, which is significantly higher than the outer core. What's fascinating is that despite the extreme heat, the materials in the inner core remain in a solid state. This is because of the immense pressure deep within the Earth, which prevents these materials from melting. So, to answer the question of why the inner core of Earth is hotter than the surface of the Sun, it's due to the incredible pressure deep within our planet, which keeps the inner core solid despite the high temperature. This unique combination of pressure and temperature is what makes Earth's inner core solid and extremely hot. It is believed that Earth's formation occurred approximately 4.6 billion years ago from a solar nebula. When our Earth was formed, it was a seething ball of lava. Over time, the Earth's surface cooled, and the heat trapped within it remained confined beneath the solid surface. Lighter elements in the Earth rose to the surface, while heavier elements sank towards the core. One theory suggests that during the formation of planets in our solar system, some planets had unstable orbits, leading to collisions with each other. It is believed that such a collision occurred with a planet named Theia, which resulted in a catastrophic impact on Earth. This impact led to a significant increase in Earth's temperature, and the intense heat generated from this collision still resides deep within Earth's core. This is one of the reasons why the Earth's core is extremely hot. Scientists also believe that the formation of heat within the Earth's core is influenced by radioactive decay. Uranium, thorium, and potassium are present in the Earth's crust and mantle, and they contain radioactive isotopes that continue to decay over time, producing heat. This heat travels into Earth's core, further raising its overall temperature. However, it would be incorrect to say that the temperature of Earth's core is hotter than the Sun because, just like Earth, the Sun consists of different layers. The core of the Sun, which is its center, acts as a source of energy through nuclear fusion. Nuclear fusion reactions occur in the Sun's core, producing both light and heat. The temperature in the core of the Sun is approximately 15 million degrees Celsius, which is indeed much hotter than Earth's core. The layer just above the Sun's core is called the radiative zone. It is a region where energy, in the form of light, takes about 100,000 years to travel from the core to the surface. This is in contrast to the mere 8 minutes and 20 seconds it takes for light to travel from the Sun to Earth. Beyond the radiative zone is the convective zone, where heat is transported by convection currents. Finally, there is the Sun's outermost layer, which we see from Earth, known as the photosphere. This layer is not solid but consists of a vast, 482-kilometer thick plasma layer. It is through this layer that the energy produced in the Sun's core thousands of years ago makes its way out into space and is felt on Earth about 8 minutes later. The temperature of the Sun's photosphere is around 5,500 degrees Celsius. To sum up, when we were discussing the Earth's core having a higher temperature than the Sun, we were referring to the outermost layer of the Sun, the photosphere. However, the Sun's other layers, such as the core and the subsequent regions, also play crucial roles in its overall composition and energy production. We will explore these layers in more detail in another video. If you found this video informative, please like it and subscribe to the channel for more such videos. Don't forget to hit the bell icon.